Hi everyone, this is grade 10 term 1 revision. I'm going through different past exam question papers. Please subscribe to Maths Level Up channel. Also do not forget to like, share my videos so that it reaches many people as possible. For those who are based in Gauteng, so if you are around Vosloorus, we have Saturday classes that are based in Nageng Primary School. You can come and join. We offer maths and physical sciences, grade 10 and grade 11. So let's start. So the first question here, we are required to factorize. So remember, with factorization, you need to remember 5 types of factorization in grade 10. There is number 1, common factor. Number 2, we have difference of two squares. Number 3, trinomial. Number 4, grouping. And number 5, the sum and the difference of two cubes. So now let's check number 1 here. Number 1, we are given x to the exponent 4. And we can see that the exponent is an even number. So we can divide the exponent by 2, minus 81. And we can see that 81 is the same as 9 times 9. So 81 is a perfect square. So this is a difference of two squares. So to factorize the difference of two squares, we are going to open two brackets. One has plus and then the other one, there is minus. So if we divide this exponent by 2 here, we are going to have x squared. Even here, you just put x squared. And we said 81 is the same as 9 times 9. You just put 9 and 9. Now, you will then notice that, again, after factorizing, you still have another difference of two squares. Because this 9 here is the same as 3 times 3. So, unfortunately, there is no sum of two squares. So, this one, we cannot factorize it further. So, we will bring it as it is. So, we have x squared plus 9. And then we can factorize another difference of two squares. So, which will be x minus 3 and then x plus 3. And then we have factorized fully. So, let's move to the next one. 1.2. Here we have 4 terms. So, if you have 4 terms, you need to think about grouping. It can be 4 terms, 6 terms, even sometimes they can go up to 8 terms. But with this one, we can group the first 2. We can also group the last 2. So from the first 2, I'm going to take out the common factor. So we do have a number that can divide into 6, into 10 as well. That number is 2. So our common factor here in the first 2 terms will be 2xy. So, and then you are going to remain with 3x minus 5. And then if you look at the last 2 terms, our common factor will be 5. And then you will remain with 3x minus 5. Now again, after factorizing, you realize that you still have another common factor here. You can take it out again. So the common factor is 3x minus 5. And then in the first term now, you remain with 2xy and then plus 5. And then you have factorized fully. Simplify the following expression fully. 1.2.1. So here we can see that we are adding and subtracting fractions. So we need to take LCD. But before we even take LCD, we need to sort this out first. We need to factorize this trinomial. So we are going to have 3 over a minus 4 plus 2 over, it is a plus 3, and then minus, we have 21 all divided by. Now we need to factorize this trinomial. Okay, so we are looking for factors of 12. Factors of 12 are 12 and 1. It's 6 and 2. And then 4 times 3. But the factors that we are looking for, since 12 is negative, we need to subtract them, and they must give us 1, because the number in front of a is 1. Now it will be 4 minus 3, because 4 minus 3 is 1. So we are going to have a, and then we have 4 and 3. Now the signs are different since 12 is negative. The middle term will correspond with the bigger number. 4 is bigger than 3. So it will be minus here since the middle term is negative, and then it will be plus there. So now our LCD from this will be a minus 4, and then a plus 3, because each denominator must be represented. So we can see that here is a minus 4, a minus 4, a minus 4, a minus 4, a plus 3, a plus 3, a plus 3, a plus 3. So each term is represented. Now, to find the numerator, there are so many methods, but the one that I prefer is to multiply each term by LCD. So if I multiply each term by LCD, okay, I'm going to have 3 over it a minus 4. What is my LCD? It is a minus 4 into a plus 3. So this and that will cancel. So we are going to remain with 3 into a plus 3. Okay. Multiply the next term with the LCD also. I will have 2 over a plus 3. What is my LCD? It is a minus 4 into a plus 3. So this and that cancels. So you are left with 2 into a, my LCD is not a minus 3 here, it is a minus 4. So you are left with 2 into a minus 4. Okay. Last term multiplied by LCD also. We have a negative 21 into a minus 4 into a plus 3. So our LCD is a minus 4 into a plus 3. So this and that cancels. So you are left with negative 21. And then from here, we can just remove all the brackets in the numerator. So if I remove all the brackets in the numerator, we are going to have, this is our a minus 4, a plus 3, our LCD. So we are going to have a 3a plus 9 plus 2a minus 8 minus 21. So add the like terms. So we are going to have a minus 4, a plus 3. Now the like terms, 3a plus 2a, that will be 5a. And then 9 minus 8, that is positive 1. Minus 21, it will be minus 20. And then we can see we still have a number in the numerator that can divide into 5, that can divide into 20 as well, which is 5. So 5 is a common factor. We have 5 as a common factor, and then we are going to have a minus 4 divided by a minus 4 into a plus 3. Now, this and that cancels, so the final answer here is 5 over a plus 3. So that is your final answer. Okay, let's move to the next one. Okay, 1.2.2, 1.2.2. We have 10 to the exponent 2x plus 3 times 4 to the exponent 1 minus x, all divided by 25 to the exponent 2 plus x. So here we are dealing with exponents. So the golden rule here is to make sure that the bases are written as prime factors. So now 10 is the same as 5 multiplied by 2 to the exponent 2x plus 3. 4 is the same as 2 squared to the exponent 1 minus x divided by 25 is the same as 5 squared to the exponent 2 plus x. And then from here we are going to remove the brackets. So if we remove the brackets here, remember this exponent belongs to 5. It is also belongs to this 2. So it will multiply the exponent of 5, which is 1. It will also multiply the exponent of 2, which is also 1. So we are going to have 5 to the exponent. It is 2x plus 3 times 2 to the exponent 2x plus 3 multiplied by, and then 2 times 1, it will be 2. And then 2 times negative x, it will be negative 2x. All divided by, let me use a different color. All divided by, so again, we remove the bracket, we are going to have 5. And then we have 2 times 2, which is 4. And then we have 2 times x, which is plus 2x. Now, you will notice that we have 2 different sets of bases. Everything that is coming from underneath, the signs will change. So the first base is 5, so we are going to keep 5. And then this one, we write it as it is above. So it will be 2x plus 3. And then this one is coming from underneath, so it is minus 4. Coming from underneath, so it is minus 2x. Multiply by 2, everything is above, so we take the exponents as they are. So it will be 2x plus 3 plus 2 minus 2x. And then if we add the like terms here, we are going to have 5, and then 2x minus 2x is 0. 3 minus 4, it will be negative 1. Multiply by 2. 2 minus 2 is 0. And then 3 plus 2 is 5. So 2 to the exponent 5. So this is the same as 32. Factorize the following expression fully. Okay, we are back to factorization again, where you need to remember all types of factorization. Now, I think here we can see that we have 2 terms, and then there is a common factor. We can see that we do have x. Even here we do have x, we do have y. We do have y in each term. So the common factor into 0.1, we have our common factor as xy. And then if we divide the first term by xy, we are going to remain with y, and then plus 3x. And then that is why this one is just only 1 mark. It is very simple. So 2.1.2. So we have a trinomial, 3 terms, x squared minus 7x minus what? Minus 18. So with this one, we are looking for factors of 18. We write them down. It will be 18 times 1, 9 times 2, and then 6 times 3. So the factors that we are looking for, since 18 is negative, so we need to subtract them. And when we subtract them, they must give us what? They must give us 7. So we can see that 18 minus 1 is not 7. 9 minus 2 will give us 7. So that means our factors are x, and then we have 9 and 2. Now, the middle term is negative, and the last term is also negative. So signs are different here, since the last term is negative. So if signs are different, the bigger number will correspond with the middle term. So we have minus and plus. And then we have factorized this expression. So the factors are x minus 9, x plus 2. Okay, let's move to the next one. Uh, 2.1.3, we can see that we have 4 terms. So 4 terms, we need to think about grouping. So now we need to see how can we best group these terms. So we can group x squared y, and then we can group it with negative 4x squared, so that we will be able to take out the common factor. And then plus, we can group a 4y. We can group that 4y with what? Negative 16. So now, from the first 2 terms, we can take out the common factor. The common factor will be x squared. So if x squared is taken out, we are going to remain with y minus 4. And then in the last 2 terms, we can take out the common factor, which is 4, because in 4 there is 4. Even in 16 there is 4. So we have 4 as a common factor, and then we are going to have y minus 4. And then now we can see that we now have 2 terms, 1, 2. Now again, among these 2 terms, there is a common factor, which is y minus 4. We can take it out again. So we have y minus 4, and then we are going to remain with x squared plus 4. So we have factorized fully, because there is nothing we can do with this one now. And this is a sum of 2 squares. So the sum of 2 squares cannot be factorized. And then let me move to the next one. Now we are required to simplify the following expression fully. Okay, here we have a product. So we just need to remove these brackets. So each term in the first bracket will multiply every term in the second bracket. So we are going to have 2x multiplied by 2x multiplied by x squared. It will be 2x cubed. 2x multiplied by negative 3x. It will be negative 6x squared. 2x multiplied by 1. It will be 2x. And then we have negative 1 multiplied by x squared. It will be negative x squared. And then we have negative 1 multiplied by 3. It will be positive 3x. And then we have negative 1 multiplied by positive 1. It will be negative 1. And then from here, I can just add the like terms. So I can see this one goes with that one. I can see also that this one goes with that one. Now we are going to have our final answer as 2x cubed, and then negative 6x squared minus x squared. It is negative 7x squared. And then 2x plus 3x, it will be 5x, and then minus 1. So this is our final answer. We have simplified the expression fully. Okay, let me move to the next one. Now here we are given 2 to the exponent negative 2n multiplied by 3 to the exponent negative 3n, all divided by 2 to the exponent 2n multiplied by 4 to the exponent n minus 1 multiplied by 12 to the exponent negative 3n. Now, when you are dealing with this nature of question, you need to make sure that all the bases are written as the products of their prime factors. Now, we can see that 2 is already a prime number. 3 is already a prime number. 2 is also a prime number. But now with this 4, we need to change it. 4 is not a prime number. 12 is not a prime number. So we need to change these numbers first so that all the bases are written as the products of their prime factors. So we have 2 to the exponent negative 2n multiplied by 3 to the exponent negative 3n, all divided by, we have 2 to the exponent 2n multiplied by, now what is 4? 4 is the same as 2 squared to the exponent n minus 1 multiplied by 12 is the same as 2 squared multiplied by what? Multiplied by 3, all to the exponent negative 3n. And then we are going to remove these brackets. So we are going to have 2 to the exponent negative 2n multiplied by 3 to the exponent negative 3n, all divided by, so we have 2 to the exponent 2n. And then remember the laws of exponents. Here, these exponents will multiply. So we are going to have times 2 multiplied by n, it will be 2n. 2 multiplied by negative 1, it will be negative 2. Multiplied by, and again, remember with this one, so this 2 here will multiply this exponent. Even this 1 there, remember, if there is no exponent written, we know it is 1. It will also multiply that negative 3n. So we are going to have 2, and then 2 multiplied by negative 3n, it will be negative 6n, multiplied by 3, or negative 3n multiplied by 1, it will be negative what? It will be negative 3n. And then from here, we can see that we have 2 different sets of bases. There is a base of 2. We also have a base of 3. Okay. So we follow the laws of exponents. So we are going to have 2. And then now everything that is from the numerator, every exponent from the numerator, we keep it as it is. So it is minus 2n. And then everything that is coming from underneath, the sign will change. So we have 2n, which is positive. So it will be minus 2n. It is coming from the denominator, right? We have this 2n is positive. It will be minus 2n. And then this negative 2, that will be plus 2. And then this 6, it will be plus 6n. And then times, we have 3. And then we have negative 3n. This one is coming from underneath. So it will be plus 3n. So now here, we have like terms. So this, that, and that one. So minus 2 minus 2 minus 2 plus 6, it will be 0. So we are left with 2 to the exponent 2 multiplied by, with that one, this and that, and then they cancel out. So we have times 3 to the exponent 0. So 2 to the exponent 2 is 4. 4 times 3 to the exponent 0. It will be 4 times 1. The answer is what? The answer is 4. And then let's move to the next one. Here we have exponential equations. So we are required to solve for x. So now, with exponential equations, you need to remember the law that says, if I have a to the exponent y is equal to a to the exponent x, as long as these bases are the same, therefore exponents are equal. So here I can say y is equal to x. So when I'm dealing with these exponential equation, my ultimate goal is to make the bases the same. So number 1, which is 3.1 in this case, we have 5 to the exponent x plus 2 is equal to 1. So remember, we can write this one as 5 to the exponent 0, because any number to the exponent 0 is 1. So here we have 5 to the exponent x plus 2 is equal to 5 to the exponent 0. Now we can see that the bases are the same, so therefore exponents are equal. So we have therefore x plus 2 is equal to 0, and then therefore x is equal to, if we transpose that, negative 2. So x, if we transpose 2, your x will be negative 2. Next one. We have 3 to the exponent 3x plus 2 is equal to 27. 27 is the same as 3 to the exponent 3. So now again, this is 3.2. Now we can see the bases are the same, therefore exponents are equal. So therefore we have 3x plus 2 is equal to 3. Okay, this is equal to that. Now, transpose 2. I will have 3 minus 2, which is 1. So I will have 3x is equal to 1, then divide by 3 on both sides. So therefore x is equal to 1 over 3. Last one, we have 2 to the exponent x plus 1 minus 2 to the exponent x is equal to 16. With this one, I can see that I have more than one term. So I can just split this. This can be written as 2 to the exponent x multiplied by 2 to the exponent 1 minus 2 to the exponent x is equal to 16. So now there is a common factor. If I check my left-hand side, 2 to the exponent x is common. I take this 2 to the exponent x as a common factor, and then I remain with 2 to the exponent 1 minus 1 is equal to 16. So this is 2 to the exponent x. 2 minus 1 is the same as 1, so is equal to 16. Now, I will have 2 to the exponent x is equal to 16 is the same as 2 to the exponent 4. Therefore, x is equal to 4. Let's move to another paper. I think that is the last one for part 1. I'll do another video. Please, guys. Now, last set of questions before we end this video. So please do not forget to subscribe, like, and share. Now, here, the first question, we are required to indicate whether each of the following number is rational or irrational. So you need to understand that irrational can be expressed as a fraction, right? Irrational can be expressed as a fraction, a over b, where a is an integer, even b is an integer. And you need to remember that all the perfect squares are rational. All the recurring decimals are rational. Okay? For example, if I say recurring decimals, 1,1111111, 5,2323232323. So those are rational numbers. Now let's see here. We are given a square root of 15. Number 1, we are given root 15. 15 is not a perfect square. So now this one is irrational. Irrational. And then number 2, we are given 2,5. Remember, 2,5 is the same as 5 over 2. So this is the same as 5 over 2. So you can see that it can be written as a fraction. So now this one is rational. And then we are given the cube root of 8. Cube root of 8. Cube root of 8 is the same as 2, which is 2 over 1. So this one is also rational. Okay, last one. We are given 2,33333. So this one is recurring. The decimal is recurring here. So it is also rational. So number 4, 2,3333 is rational. So the only irrational number here is square root of 15, because 15 is not a perfect square. The rest are rational. Let's move to the next question. Write down 2 rational numbers between square root of 2 and square root of 10. With this one, you need to know your perfect squares. So you need to know your perfect squares. Square root of 1, 1 is a perfect square. We have square root of 4, 4 is a perfect square. Square root of 9, square root of 16, square root of 25, square root of 36, square root of 49, and so on and so on. So we can see that the ones that are between, we are looking for the ones that are between 2 and 10. So it will be square root of 4 as well as the square root of 9. So your answer for 1.2 is the square root of 4 and the square root of 9. Okay. Move to the next question. Write down 0,111111 as a fraction. So sometimes in the test or exam, they will say to you, show that 0,111111 is rational. So remember, rational numbers can be written as a fraction. So now here we say let 0,111111 dot it continues be what? Be equal to x. So now if it is only one number that is recurring, you multiply it by 10. If you have two numbers that are recurring, you multiply it by 100. If three numbers are recurring, you multiply it by 1,000. Here we only have one number that is recurring, so we will multiply by 10. So if we multiply by 10, we are going to have this is equal to 10x is equal to 1, comma, because we are multiplying both sides. 1, 1, 1, 1, 1, 1, 1 recurring. And then we are going to say equation 2 minus equation 1. And then we have 10x minus x. It will give us 9x is equal to, and then 1, 1, 1, 1, 1, 1, 1, 1, minus 0, 1, 1, 1, 1, 1. This will cancel that side, and then you will remain with 1 here. And then we divide by 9 on both sides. So x is equal to what? X is equal to 1 over 9. So that simple means 0, 1, 1, 1, 1, 1, 1, 1 continues is the same as 1 over 9. Okay, let me move to the next one. The next question we have x to the exponent 3 minus 8. X to the exponent 3 minus 8. Now, we can see here that we can divide exponent by 3. And then 8 is the same as 2 to the exponent 3. So now here we have a difference of 2 cubes. To factorize the difference of 2 cubes, okay, we are going to have x minus 2. And then now to find the very first term in the second bracket, we are going to square this. So if we square x, we will have x squared. To find the very last term, we are going to square that one. So if we square 2, we are going to have 4. And then now to find the middle term, we multiply the 2. So you just say 2 multiplied by x, which is 2x. And then if you have a difference of 2 cubes, all the signs in the second bracket are positive. So it's positive and positive. Okay, that is number 1. So x to the exponent 3 minus 8 can be factorized as x minus 2 into x squared plus 2x plus 4. Let me move to the next. Plus x squared minus 6x minus 3. So you can see that we have 4 terms here. So we can group. These two. We can also group the last 2. So now we can see among the first 2 terms there is a common factor, which is x squared. We take x squared out as a common factor, and then we are going to remain with 2x, and then plus, it is 2x plus 1. And then we can see that we have a number that can divide into 6 and 3. That number is 3. We can take negative 3 out as a common factor. And remember, when negative is taken out as a common factor, the signs will change. So here you are going to remain with positive 2x plus 1. Now, you see now that we have two terms now, 1, 2. And now, among these two terms, this one and that one, they appear in both terms. So 2x plus 1 appears in both terms. So we have another common factor. So we are going to take it out, 2x plus 1, and then we remain with x squared minus 3. Now we have factorized this fully. Okay. And then 1.4.3. No, it's 1.4.2, this one. 1.4.3. We have x to the exponent 4 minus 16. Again, we have two terms. We can divide 4 by 2. So x to the exponent 4 is a perfect square. 16 is also a perfect square. It is the same as 4 times 4. And then this is how we factorize difference of two squares. We have x squared, x squared. 16 is 4 times 4. And then we have plus and minus. You will then notice again, after factorizing, that this is still a difference of two squares. So we are going to have our final answer as x to the exponent 2 plus 4. And then we factorize the difference of two squares again. So now it will be x minus 2, x plus 2, because 4 is the same as 2 times 2. Okay, let's move to the next one. So the last 3 questions now. Simplify the following expression fully. So here we are given the product. So we just to remove these brackets and add the like terms if there are any. So we have 2x minus 1 times x squared minus 2x plus 1. You need to remember that everything in the first bracket will multiply everything in the second bracket. So we are going to have 2x multiplied by x squared. It will be 2x cubed. And then we have 2x multiplied by negative 2. It will be negative 4x squared. And then we have 2x multiplied by 1. It will remain as 2x. And then we have negative 1 multiplied by x squared. It will be negative x squared. And then we have negative 1 multiplied by 2x. It will be positive 2x. And then lastly, we have negative 1 multiplied by positive 1. This will give us what? A negative 1. Now, there are like terms here because this goes with that and this goes with that one. So the final answer is 2x cubed and then minus 4x squared minus x squared. It will be minus 5x squared. And then 2x plus 2x, it will be plus 4x. And then minus what? Minus 1. And then we have simplified that one. Let's quickly move to the next one. Here we are squaring a binomial. So we have 3x plus 5 all squared. So when you are squaring a binomial, you can just square the first term here. So we have 3x squared. Multiply the 2, then times it by 2. So we have 3x times 5, and then all times what? All times 2. And then you square the last term. So you just say plus, and then you have 5 squared. So the final answer here will be 9x squared. And then 3x multiplied by 5. It will be 15x times 2, so it will be plus 30x. And then 5 squared, this is plus 25. And then we are done with this one. The last one, we have 2 to the exponent x minus. So this operation is key here. 2 to the exponent x minus 2, all divided by 2 to the exponent x plus 1 minus 2 to the exponent x. And then we can split this one here. We have 2 to the exponent x minus 2 to the exponent x times 2 to the exponent negative 2, all divided by 2 to the exponent x times 2 to the exponent 1 minus 2 to the exponent x. And then you'll notice that this in the numerator and that one are common. They must be taken out as a common factor. Even in the denominator, this and that are common. They must be taken out as a common factor. So we are going to have a common factor of 2 to the exponent x, and then we remain with 1 minus 2 to the exponent minus 2 divided by 2 to the exponent x into, and then here we are left with 2 to the exponent 1 minus 1. So now this and that divides, so we are left with, in the numerator, 1 minus 1 over 4, because 2 to the exponent minus 2 is the same as 1 over 4 over what? Over 1. And then what is 1 minus 1 over 4? It will be, the final answer here will be 3 over, it will be 3 over 4. And then I'm done with the first part. So please make sure that you like, you share, and subscribe. Thank you very much for watching. I hope this video did help you. I'm going to do another one for equations, where I will be doing, or where I will be dealing with inequalities, simultaneous equation, solving quadratic equations, exponential equations, etc., etc. Thank you very much for watching.